we are in the properties of whole number. So we start this topic. So in the properties of whole number, first property is closure property. So in the closure property, we will discuss various operations. We start with the addition. If you take any two whole number and add them and observe the sum carefully. Suppose you have the number 4 plus 5, it is 9, that is the whole number, where 4 and 5, these are the whole number. So closure property means in any operation you are using whole number, the result should come in whole number. So 4 and 5, these are nothing but whole number, and in answer we have the whole number. Next example, 8 plus 4 is 12. So in input we have the whole number like 8 and 4, and in result also 12 is nothing but whole number. If you take 90 plus 0, where 0 is also whole number, and in answer we have 90, that is also the whole number. So this property is belonging to the closure property. In the multiplication, if we observe the product, then 7 into 8 is 56. 7 and 8, these are the whole number, 56 is also whole number. Then 5 into 6 is 30, 30 is also whole number. 0 into 15 is 0, 0 is also whole number. So both the property, both the operation, addition and multiplication, they satisfied under the closure property. Next one we will see is a subtraction. So in subtraction, if you take two whole number, observe the difference. 5 minus 3 to 2. So 2 is whole number, 5 and 3, these are the whole number you can say. And 6 minus 9. We are taking the whole number in the subtraction. 6 and 9 both are the whole number, but minus 3 is not a whole number. Same 7 minus 2, 5 is whole number. So subtraction, in some cases it is satisfied, some cases not satisfied. So overall subtraction property is not satisfied under the closure property. If you take division operation, if you take any two number, suppose 8 and 2, these are the whole number. 8 divided by 2 is 4, 4 is whole number. But if you do 2 divided by 4, answer is half, 1 and 2. So that is not the whole number, that is a rational number. If you do 9 divided by 3, 3 is a whole number. So division also, sometime it is satisfied, sometime not satisfied. So you can say subtraction and division not satisfied under the closure property. So whole number are closed under addition and also under multiplication, but not closed under subtraction and the division. Next one is division by 0. Division by a number means subtracting that number repeatedly. So here our topic is division by 0. Before that we will see what exactly division operation, why we use division. So let us find 8 divided by 2. What we do? 8 minus 2 is 6. Okay, in subtraction. Again, if you do 6 minus 2 is 4, 4 minus 2 is 2, 2 minus 2 is 0. So we continuously do this subtraction till we get the 0 value. So if you suppose divide 8 by 2, this is nothing but 8 minus 2 is 6, 6 minus 2 is 4. We do this till we get 0. So we are doing this how many times? 4 times. So that's why this answer is 4. 8 divided by 2 is 4. Subtract 2 again and again from 8. After how many move did we reach 0? That is known as the division operation. So we write 8 divided by 2 is 4. This is nothing but this operation. That is what division. So important note, in the division by 0, divide by 0 is not defined. Why it is not defined? Let us see with example. 9 divided by 0. So 9 minus 0 is 9. Again 9 minus 0 is 9. We are not reaching to 9. It means in every step we get the same result. This will never stop. So we can say division by 0 is not defined. That's why we don't divide any number by 0. Next one is commutative property. So under the commutative property, formula is there. Okay, like A plus B equals to B plus A. I show you this formula. In the commutative property, it is nothing but under the addition, it is A plus B. It is nothing but B plus A. That is what the commutative property. So this is what commutative property. Here A plus B is nothing but B plus A. So here in this example you observe 5 plus 4 is 9 and 4 plus 5 is 9. We have the same result if you reverse the number, if you change their order. So that is what 4 plus 5 is nothing but 5 plus 4. So this shows that we can add whole number in any order. So addition is satisfied under commutative. Next is multiplication, also same, 5 into 4. You can also write 4 into 5. These both are same. So this shows that we can multiply whole number in any order. So both are satisfied under the commutative property. So in the subtraction operation, 7 minus 5 is 2, but 5 minus 2 is not 2, it is minus 2. So therefore both are not same. So hence subtraction is not commutative. Next one is division, also same. 6 divided by 2 is 3 and 2 divided by 6 is 1 by 3. We are getting different result. Both are not same. So it means division is not commutative, associative. Under associative property we have the first addition. So associative property means, in the associative property generally we write plus C. So what happened, friend, if suppose I group here A and B, and you can also write here, you can also change their group like B plus C. Okay, so this is nothing but B. So A plus B plus C, here A and B we will solve first, then we will solve C. You can also solve A plus B plus C, where you can solve B plus C first and then you will solve A. That is what associative property means. We change the group, means you can change their bracket. Okay, here the bracket is enclosed in A plus B, here bracket is enclosed in last two, but in both the case we have same result. Like here 1 plus 2 plus 3, first we solve 1 plus 2 3, 3 plus 3 6, 1 plus 2 plus 3, first we solve 2 plus 3, that is 1 plus 5 equal to 6. So it means both are same. Got that? It means this equation is satisfied. The result are same even if we change the grouping of number. So addition is satisfied under associative. Next, multiplication also. If you write 2 into 3 in bracket, out of these 3 we will solve bracket first. 2 into 3 is 6, 6 into 4 24, 2 into 3 into 4 we will solve bracket first. 4 into 3 12, 12 into 2 24. So these both are same. So it shows that multiplication is also belonging to associative property. Next one is subtraction. In the subtraction, if you have 5 minus 3 minus 2, we will solve bracket first. 5 minus 3 2, 2 minus 2 0. If we change the group, if we solve 3 minus 2 first, then 3 minus 2 is 1. It is subtracted from 5, so it is 4. Both result not same, it means they are not equal. It means this shows that the result are not same if we regroup the number except in certain cases. Example, 3 minus 2 minus 0 equals 2. 3 minus 2 is 1, 1 minus 0 is 1. If you write 3 minus 2 minus 0, so 3 minus 2 equal to 1. So in some cases it is true, but overall subtraction doesn't follow the associative property if it is not true in one case also. Next one is division. So in division it is same like subtraction result. 12 divided by 3 divided by 2, we will solve bracket first. So it is 4 divided by is 2 equals to 2. Then we will solve bracket. 3 divided by 2 is 1.5. 12 divided by 1.5 is 8. So both result are different. This shows that result are not same except in certain case, like 6 divided by 3 divided by 1. So 6 divided by 3 is 2. 2 divided by 1 is 2. If we regroup like that, 6 divided by 3 it is 2. So in some cases it will be true, but if it is not true in one case also, then overall division is not satisfied under the associative property. So distributive property. So in distributive property we use like that, A into B plus C. So it is nothing but A into B plus A into C. This is what the distributive property. So distributive over the addition we will see. So distributive of multiplication, because 50 is multiplied, so that's why distributive of multiplication. Over addition means in bracket we use plus sign. So in example we solve the bracket first. 15 into 10 is 150. One more example, it is particularly used for making the answer for calculation, for making the calculation simple. For doing this we use distributive property. So because of distributive property we get the calculation in a easy way. So suppose you are solving this, then what happen, 290 into 105 is nothing but 100 plus 5. So you can easily multiply this 290 into 100 plus 290 into 5. Then you can easily multiply any number into 100. So 290 into 5. So finally whatever the answer you get, you have to do their addition, you get the result. So for making the exercise or making the product addition, for simple way we use the distributive property. Then in the distributive property, next part is multiplication over subtraction. So what you can solve the bracket first. So 20 into 10 is 200. We will take one example like 200 into 98. So 98 can be written like 100 minus 2. You see 100 minus 2. Finally you do multiplication with 200 into 100 minus 200 into 2. Whatever result you do the subtraction, you get the result. So whenever you get the question like that, you have to use distributive property. Additive identity. Additive identity means if you are adding particular number in the addition and you get the same number, that is what additive identity. For example, if the number is 5, whole number is 5, if you add 0 you get the same number, or if you do 0 plus 5 you get the same whole number. So that is what 0 is the additive identity of whole number. Okay, because we are getting the same number. Multiplicative identity means it is 1, because if you multiply any number by 1 we get the same number. So 9 is a whole number, 9 into 1 is 9, 7 into 1 is 7. We are getting the same number written back. So that is 1 is a multiplicative identity. Multiplication property of 0. If you multiply any number by 0, okay, if you multiply any number by 0, then we get the 0 answer. So 0 plays a special role in multiplication. Any number even multiplied by 0 become 0. So that is very important property. So whatever we have seen in this presentation, if you understood this, then you can easily solve the exercise part. Got it? So I hope friend you understood this tutorial. Thanks for watching. Thank you.